Thanks, Brad. Yeah, I did manure management plans for about 15 years, so this is a pretty familiar topic. Just curious, if you raise your hand if you work with a farm or on a farm that uses or produces manure or consult with people. Okay, we got a lot of people here. All right, well, you're my people. So thanks again for the invite and glad to see everyone here. This is some facts from a survey that Minnesota Department of Ag did in the late teens. And just across Minnesota, from their survey, about 65% of that manure is applied in the fall. I mean, most of you know it's a little more of a window, a little drier usually. Storage concerns, that's kind of, a lot of why it's more majority in that way. On average, manure travels about 1.4 miles from a barn. The more watery and liquid usually it's closer. Drier, like poultry manure, can get trucked a little further. One interesting fact, about 27% of farmers knew the actual amount of manure and applied. So that's the tricky part here, especially when we're thinking about the 4R of the right rate and source. Like, okay, it's not like commercial fertilizer, the exact NPK. We're dealing with a moving target here. So to look at that, we're going to just quick look at this chart of samples taken from the Midwest region from 2012 to 2022, and the colorful shape is what the middle value of that number. So out of 74,000 liquid swine samples, the middle number was around 40 pounds of N per 1,000 gallons, for example. The top bar is the 75th percentile, the bottom is the 25th percentile. So that's just half the samples of that are in this range. So that's a huge range when we're talking about nitrogen. All these guys have been talking to you about the different forms of nitrogen. The ammonium N, that's the inorganic part, the part that's ready for plants to use. And the other part would be the organic N, that would be more of a slow release portion. So in this particular case, maybe around half is in that inorganic ammonium form. Then we got phosphorus and potassium. So here we can look at some other sources. Here's solid turkey manure, solid beef manure, liquid dairy, and solid dairy manure. And you can see some of those, we have like 42,000 samples here through the Midwest, the middle sample, the 75th and 25th, so it's a little tighter band in that case, but you can kind of see the overall patterns anyways. There's different ratios of the nitrogen to phosphorus, which can be sometimes tricky, depending on how much they've been overloaded, or do you have high phosphorus soils, and what kind of crop rotations are you using, all those different things. So, that's just one really big moving target, like what do you even have to begin with? And I think the bottom line here is, try to get tests of what kind of manure source you're working with. So at least we can start to do that. And then you can kind of start to tackle, well, what rate are we doing? Are we calibrating? How we're spreading? And all that sort of thing. Talking again kind of about the different forms of nitrogen in manure. These liquid manures, here's swine, dairy, beef. This maroon part is that inorganic N fraction, that ammonium N. So you can see a lot of them are over half, and swine has even more than that. In the solid manures, it's a lot smaller portion. A lot of that is, tied up in that organic N in that part. So it's going to be a little slower release portion. And we also have to think about credits the year after, because it is slow release, and depends on the weather. Like if we all knew the weather, that would what's going to happen, that would help out too. This has kind of been mentioned out throughout the day too, about just different climate trends. Here's our average temperature for the 30 years from 1991 to 2020, and then now that departure from 1981 to 2010. A little cooler on average in the February through April, but in the fall you can see we're kind of trending a little bit warmer. And we just know from that fall application, whatever nutrients you do put out, that is a long time until that crop is going to take it up next summer. That's just a long time to sit out there in the soils. And if if our temperatures are trending warmer, that just is another increased risk of nutrient loss. Okay, so what can we do 4 best management practices for fall manure. We're going to go through a few of these different things, applying, after these soil temperatures have cooled down. Talk about different possibilities for nitrification inhibitors, and then also has been discussed, what are some things we can do possibly with cover crops. And I think, there's been charts and different things. Cooler temperatures reduce nitrogen losses. That's optimal range for nitrifications between that 60 and 100 degrees. Past 75, it's just unlimited. So it's one of the things where everyone's like, well, wait till it's below 50 degrees and trending cooler. That's the reason why. We want to try to hold it in that ammonium form as long as we can. Again, why wait till 50 degrees? In that ammonium fraction, that's the part that it's not susceptible to water loss, because as Brad was saying earlier today, it's being held to the soil. But however, when it switches, it goes through the nitrification process, then it can be lost through leaching. So here's just a quick incubation thing. At maroons at 45 degrees, yellows at 60. You look after 9 weeks, there's hardly any ammonium left. However, when it's at 45 degrees, it's decreasing, but at a slower rate. So just multiple ways to show this. This was just a kind of a simple experiment Melissa Wilson's lab did. They took some dairy manure and they took some swine manure, and they put some in the refrigerator and they put some on a countertop, and then checked it after 28 days. So the 40 degrees is the refrigerator, 73 was the counter. So in this fraction, the 40 degree, the refrigerator ones for dairy and swine, they still had quite a bit of ammonium left, and a decent amount of nitrate. However, the ones that were out on the countertop, just look how much nitrification had happened, in 28 days. So that form is, things are happening when that temperature is warmer. And as Brett said, either one's fine. The plant can take up either one. We're just concerned, once it moves to that nitrate, how it can possibly leave the system with water. So takeaway, we're really trying to apply manure in the fall after the soil temperatures are below 50 degrees. And if you really absolutely cannot wait, every bit cooler is better. 55 is better than 60. 60 is better than 65. All those, just trying to do as cool as you can do it. All right, switch gears a little bit and talk about nitrification inhibitors with manure. We'll go through a few studies that have happened here in the north central states, in Iowa, Minnesota, and Wisconsin. I'm going to talk about a study that was done in south central Minnesota. Jeff Etch actually was involved with that, so I told him earlier, hopefully I don't misrepresent this, so hopefully he'll correct me if that's true. But anyway, they were studying the effect of swine manure application on timing and the rate of nitropyrin, with the branding of instinct in this case, on yield, and then nitrogen availability. Here they used 120 pounds of available N per acre on some liquid swine finisher manure. It was sweep injected. They did 2 timings, one right after soybean harvest in early October, and then one in early November where the soil tests were soil temperatures were less than 50 degrees. They used 3 different rates. One was 0, one was the full rate of 35 ounces an acre, and one was 70 ounces an acre, the double rate. Okay, so then now this is at planting time. They did a soil inorganic N test just to see what was in there. So with no instinct, here's the ammonia in the maroon nitrate portion for the October application, and here's in the November. So this is just a timing thing in general too. Again, the later in the fall, the more was there. Full rate. They had still kept more in the ammonium fraction, and then this was the double rate. Okay, well, let's look how did this translate at the end of the year with the yields. For the October applied manure, the right after harvest, uh, with the no instinct added, blue is the full rate, yellow is the double rate. If they have the same letter, that means they were significantly the same. So here the instinct was different. They had higher yields than the no instinct. However, with the November application, the yields were all the same. So perhaps in this case, the instinct helped slow down that nitrification just long enough, to make the difference in that case. So, that's no home run. You don't know the weather. Always, it's maybe like a little bit of insurance just to slow that biological process down in some cases. Okay, now we'll go down south to Iowa and see what they did with Aaron Sassman, Dr. John Sawyer, 2010, 2013. Had a real similar setup to the Minnesota study with liquid soy manure. It was Coulter injected. Okay, so they had corn yields, no instinct, full rate, double rate. And here it looks like, again, that October one with no instinct was less than the other two. And these were pretty much the same for November applications. All right, now I'll go over to the east to Wisconsin. Dr. Carrie Lebowski and Todd Andrewski worked in the 2011 growing season, broadcast dairy manure, fall versus spring application with and without instinct. For corn grain, they did not have any yield impacts for the yield for with or without. However, they did notice with corn silage that they did have significant yield impact. So that was kind of an interesting fact. It was maybe extra plant in the leaves and everything else. I don't know what they thought there, but that was kind of an interesting finding. They did another part of a study in 2012 to 2014 with injected dairy manure with early fall, late fall versus spring, and then with and without instinct. And this is kind of looks like a lot of stuff, but they have here Arlington location, Sun Prairie, and Waterloo, the 2 different years. No manure. And this is manure, but no instinct, and then manure with instinct. And then the years with the stars are the times where it was significantly different. Here in the late fall of 2012 in Waterloo, it made a significant difference. And then in early fall 2013 in Waterloo, it made a difference. So, definitely not always that you got a yield impact in this scenario, but a couple cases. So yeah, I guess the take-home message is here, instinct did reduce the nitrification in the soil, which could be a benefit for water quality. And only improved yields when it was applied in October in some of those cases. And delaying those applications to November, even without instinct, usually, had equivalent yields. Dairy manure, however, in Wisconsin, when it came to yield, sometimes it worked, sometimes it didn't. It's not really recommended as a yield enhancement at this time. However, there could, you're keeping that nitrogen in the form of ammonium longer, so possible water quality benefit. So yeah, inhibitors help preserve some of the nitrogen until spring at several sites, but not all. So anyways, some impacts there. Now we'll switch over to cover crops and manure. Been doing some work here. We'll go through a few studies about cover crops after sweet corn and after silage. Those, you can get harvested a little bit earlier and try to get those cover crops established, and then also a study after soybeans too. All right, so first we're going to look at the testing after silage corn. What they looked at here was cover crop timing, interseeded, drilled, and then no cover crops. Early manure, late fall manure, and then spring fertilizer for comparisons here. Okay, this is just looking at the fall biomass from the cover crops following the silage corn. and fertilizer, maroon, early manure, late manure, interseed, overseed, drilled. So all kinds of combinations. Looked in the fall like the fertilizer ones had a little bit higher in these particular cases. In the spring, however, it was fairly similar between them. All right, so what's the silage corn yield after these cover crops? And this is 2 site years. You have the fertilizer, the early manure and late manure. In this case, both manure ones had higher yields than the fertilizer alone. So, and the timing didn't make a significant difference here. Looking at the effect of the cover crop, we have the no cover crop, the interseed at B4, the overseed at R5, or drilled. Again, the letters mean it's the same. They're significantly or statistically the same. So interseed or no cover crop were the same. Overseed, drilled, and no were the same. So that's how that looked out. Next scenario, they're looking after sweet corn. Here they did cover crops of winter rye, oat, rye, radish, and then none, and then early, late fall manures, and then spring fertilizers. Here's the fall biomass, all fairly in the same area. Spring biomass. I mean, oat here is none because oat winter kills, so that makes sense. In this case, it looks like this one year that the early manure had higher biomass growth, so kind of also depends on the year. Some considerations too is dealing with cover crop residues and corn emergence. Here's just some pictures. In this particular case, the winter rye with early applied manure, and then the oats with early applied manure. These winter killed, so less residue in the way, so just another thing to consider. Sometimes you can see some nutrient deficiencies. Here's the oats with the early manure compared to the fertilizer. They're able to see some visual symptoms in that case. All right, so for the corn, after the sweet corn for 2 years, we're looking at the grain yield here from between fertilizer the late September and late October. The late October here had the highest yield, and these were all different. The next year, however, the late October and the fertilizer were technically the same, but in both cases, the early fall timing had the lowest yields. As far as the effect of cover crop itself, here the no cover crop and the oats were tied, and the other two, rye and the mix, were both statistically the same. So those results for after sweet corn. Okay, the next scenario is we're doing cover crops after soybeans. Interseeded, drilled, and none, and in this case, just late manure and spring fertilizer tested at these sites. Fall biomass for overseeded and drilled, more for overseeded in this case. Probably got it out there sooner is my guess. Same 2020 and 2021. They both had more biomass for both fertilizer and late manure. In that case, this is just kind of inserted as a fun project, trying to look at some soil health properties. Maybe some of you have seen the Soil Your Undies kind of campaign to look at that. So here's an example of winter rye, late manure. You could really see some of those soil microbes working on that cotton. So here we have two. I'm going to guess which one is corn after beans and corn after corn. But yeah, sweet corn after corn is the top, and then soybean after corn. So kind of interesting to see, after about 2 months, how much those soil microbes were working in those fields. So anyways, corn yield following the soybean for 3 years. The effect of nutrient source and the timing from the fertilizer or manure, statistically, they were the same. and the effect of the cover crop, the none, overseeded, or drilled, they were all statistically the same. So as far as following soybeans, it didn't seem to make much of a difference in that yield particular case. So I guess the take-home messages with this here is to get those cover crops planted early if you can, especially if you're working with things like silage or vegetables, or I know my family, we actually grow seed corn and are able to get that out a little sooner and get cover crops planted. Trying to do as low disturbance manure injection is key when you're trying to apply into those cover crops to not disturb them as much as you can. And then applying, manure early in that fall still risks nutrient loss and reduced yield even with cover crops. So things to think about there. Okay, next I'm going to change gears into what I'm a little more familiar with because it was a project I've been working on the last few years. It's a new manure database resource called ManureDB. Just a few milestones with this project. We uploaded our first data to the database in November 2022. The website came online in 2023, and last year data downloads were available. You can just search ManureDB online and find it, or that's the website or QR code too if you're curious to look at it. As of about last month, we have over 480,000 samples from 49 states. We've been working with over 15 laboratories so far, and we have more coming. 65 animal types, 18 organic amendments. Samples range from 1998 to 2023, and we're just working on getting requested 2024 samples to come on to keep this a current snapshot of what's going on. So all this makes over 5 million data points. So it's a lot of different things. We're partnered with the Minnesota Supercomputing Institute because, I'm not a database programmer myself. How to use the ManureDB website if this is something you're interested in using. Again, we always, recommend your own manure, but there might be an interesting case for benchmarking or for new sites or just to see, what else for similar kind of manures can people expect for certain types. You can select, certain years. In this example, I selected poultry for 2018 to 2022. You can pick different units, pounds per ton in this case, for solid manure, and I selected the Midwest region. You can see what are the medians for total solids, total nitrogen, phosphorus, potassium, sulfur, and ammonium for that selection, along with that percentiles and the counts of that selection there too. You can see how these may perhaps change of the samples we have over time. There's some graphical information as well. On another tab, we have a data explorer where you can select the animal type or drill down more. The first page just has these combined categories of beef, dairy, poultry, swine, I think horse. And you can pick the region, state if you have, or a year, and again, the units. I do want to make a note, it doesn't look like there's really very many Minnesota samples on here, but the labs we work with that is in Minnesota didn't export the state with it, so they're all rolled into the Midwest region. So there are thousands of samples from Minnesota in here, they're just all embedded in the Midwest region. And then you can download that if that's something you're interested in working more with, something a little more specific. Again, they've talked about lots of fact sheets throughout. There's guidelines for manure application rates. You can search that too and find more information about that online. So I guess, just to conclude here, the big take-home, please sample your manure, get an idea of what you're working with to start with. I always say the more samples you have, the better. Each year, try to get a good composite sample if you can do. See what you can work with for your nutrient management plan. Then we have that manure, try to apply when the soil temperatures are cool or trending cooler. For liquid swine manure, consider a nitrification inhibitor if the soil temps aren't quite cool yet. And cover crops have soil health benefits. They may not correct manure applied too early in the fall, but they may help in some cases. I would like to thank all of our different funding partners, all the staff at the Research and Outreach Centers, the Wilson Lab. If you have other questions, feel free to contact myself or Melissa. So thank you very much today. If anyone else has questions right now, let me know, or I'll be around after. Yeah. Yeah.
How are the values in your analysis of the generated yield?
Comparing to book values, you mean? Yeah, how's the thing we're looking at? And that's how they started to look at this in the first place. A lot of things are different. A lot of those were published 20 years ago. I know I worked a lot with swine manure, and we knew like the phosphorus levels were a lot lower today than they were back then because of like the phytase inclusion in the feed. So yes,
This with the focus roll bar, does that affect how much DICAL are using in the rations?
yeah, they don't need as much because they're able to digest it and utilize it better, and less is undigested and exiting the system. So yeah. So I think, all these different things. Another thing is a lot of these values were taking just a snapshot of samples they had. It might only be a couple states. I mean, there's just a lot of variety here. Another thing we've seen, like there's really big regional differences in the US. They're actually just starting a kind of working group right now with the ASAB, the American Society of Agricultural and Biological Engineers, to come up with a new manure characteristics standard thing, and they're probably going to incorporate this in some way. So that effort is underway to update those book values. So yes, they're different, and yes, they're trying to update some of those ones. But yeah, as you can see, that's and we didn't even take out the different types of manure storages or bedding included. I mean, there's all these different manure treatments. Dairy farms now have a lot of digested or separated solids. I mean, there's all people compost. There's different manure treatments. I mean, there's all kinds of different things that can be done. So yeah. Yeah.
Do you have any information on end credits for manure that's incorporated versus the surface of life? How much less we have credit in is not.
Yeah, I'd have to refer back, but there's definitely a lot. I mean, if you're applying it on top, you're losing quite a lot to the environment, to the air. So just that application loss factor is quite a bit more. So anything, you can do to try to get it incorporated will help keep from losing that nitrogen anyways. But yeah, you can refer back to some of the guidance for more exact scenarios on that. But yeah, there's definitely less when you're not getting it incorporated. And the sooner you incorporate it also, makes a difference too.